Today is Veterans Day 11/11. We're going to demonstrate the Nikon equipment. It has 3 linear cameras here. The cameras are going to be looking at the LEDs, which pulse at 40 Hertz, signals back to the cameras giving the real-time position of the robot head, and the LEDs mounted on the fixture giving the position back to the fixture position of the robot. We are going to move the drill head, show the drill head down into position, drill some holes, then we're going to move the fixture and relocate the fixture, realign the robot, and show how repeatable a robot can really be in a milling process.
Recording.
Okay, this video will take about 6 minutes to run. We're going to run it in its entirety so that you can see there's no fudging or anything going on here. And you can see everything that's involved to make a truly repeatable robot. Right now we are drilling 5 holes and some clearance holes in this CFRP, which is held down by vacuum into this fixture here. So the robot is aligning with the guidance system, and then it is holding the robot stationary to drill the holes. So right now it's doing an alignment, and then it will drill the hole after the robot becomes within 2/1000ths of an inch of true positioning correct with the vision system. And now this co-worker here is going to move the, watch the fixture move to show that we can really move this fixture. All of this is working to CAD data. There's no program points by the robot at all. We're moving to 3D CAD data aligned by the vision system, by the Nikon Metrology equipment. Right now he's taking it off of the tooling pins and going to move it about 1.5 inches. Leaving it on the tooling pin or on the... Okay, now after that fixture's moved, we're going to move the robot around near the fixture and relearn the correct position of the fixture with the relationship to the robot. And now he's going to be mounting it back down. Show him this bolt hole, Mike. Here we can see that we've moved it off of the pins. The fixture was on the bolt hole here. We moved it about 1 inch off, and it's rotated also.
Just going to tighten it down here.
Tighten it back down, and you can see the LED right there in the corner of the fixture. Get a good look at the gripper on the robot. Now the robot's going to...
Now what we're doing is we're running back through a routine that looks at the relationship between the LEDs on the fixture and the LEDs on the robot head. The LEDs on the robot head are a reference frame already known by the camera system, and now it's locating the fixture relative to the robot head. Will allow the robot to know then how to go and drill the hole in the new fixture position. So after this routine, we're going to move the robot into a position of the first drill point as calculated for the new fixture, and we're going to show that we can push that drill bit right back into the same hole, which has about 1/1000th of an inch clearance.
Our intention is to move the robot back down to the last drilled position without turning on the drill bit. And then we're going to turn off the servo motor and basically push the drill bit back into the original hole that it just drilled, showing how simple and repeatable the system is. Okay, we're moving up to a line to the hole. We're going to run the same routine, going down. Move to the drill hole that we already drilled in the new reference frame. And the gentleman has to move out of the way so the Nikon equipment can see the LEDs on the robot head and the fixture. There. And the robot has just aligned itself, and now we're going to demonstrate that we can just push the drill right back into the original hole that it just made. So basically, with a thou of clearance, that robot just got
Right back into the same hole.
which is done robots for
We'll move to one other
20
point.
plus years, and having an accurate robot is something that everyone wants to see, especially when there's no teach points.
One more? Yeah.
And this was done at Wright Industries in Nashville, Tennessee. My name's J.R. Musselman. Look us up if you feel you have any interest in this application.
Okay. Okay.
Yeah. Okay, now we're going to pull the part out of the fixture. The robot out of the way and show you the holes. The holes are 1/8 of an inch.
With the
1285. That 5
caliper.
Not very important. This is
Show
a
the
common,
dimension of this hole.
Aerospace structure.
At about
And if you can see the
0.128.
micrometer there.
0.129.
0.129.
Over
And
here.
we're going to go look at the drill bit, which is
Show the
0.129.
diameter of the
Show there was no
drill bit
no
itself.
fudging going on here. This is the real
over
deal.
here. You can
And we're
see
pretty excited about this
indicator.
Right in the streets. We've been partners with
Indicator's
Nikon
about
Metrology.
127.
We developed this in the UK. And
So this demonstration shows with the Nikon equipment, you don't have to have super accurate positioning of your fixtures. You only have to have them stable into a point where you can read them with the camera system.
So there was essentially about 1/1000th of an inch positional tolerance in placing that drill bit back in a pre-drilled hole. And we proved that we could do that after moving the fixture.
Point out the pre-drilled hole in the fixture.
Pre-drilled hole?
right here. Right here's the pre-drilled holes. They're just clearance holes. That's all that is a clearance hole.
And there's the part. That's enough. That's good.
Good enough, Mike.